Class, this is your Chapter 8 test. I'm trying to do it with basically only using your calculator. Maybe a drawn or two, but mainly just the calculator. Alright, so this first question, we're trying to make a decision by claim using only the rare event rule and making subjective estimates, not necessarily computing an actual test. So here's our claim. Mean pulse rate of students is in a large calculus class is greater than 66. Okay. Simple random sample of the students have a mean pulse rate of 91.3. So way above this. Right. So the options are given me. The sample is not unusual if the claim is true. Now, if this claim is true, greater than 66, this is greater than 66, so that would not be unusual. Sample is unusual if this claim is false. If this claim were false, the opposite of greater than would be less than or equal to. So if this were false, meaning that the mean pulse rate actually was less than or equal to 66, and something this much farther would be very unusual. Alright, so then, therefore, there is sufficient evidence to support the claim. Or, sorry, not sufficient evidence. No, that's not true. So these two things are happening. It's not unusual. And there is sufficient evidence to support the claim. Right, so these two aren't right because of the fact that the sample is unusual if the claim is true. And it's greater than. It's saying it's greater than. So either one of these is right. So it's got to be one of these two. And this being unusual and this being usual. This being not unusual, this being unusual, actually supports this claim. So that's why we use our choice. Alright. But this in the claim, or the statement is high school teachers have incomes with a standard deviation more than 22,250. Alright, so more than 22,250 needs to be the alternate hypothesis. Okay, so only one of those has that as the alternate hypothesis. Remember, the H0 has to have some form of equality. So the only ones that have equality in the null hypothesis are A, B, and F. Right? And then of those, the only one that has greater than the alternate hypothesis is B. Alright, assuming we got a normal distribution, we found the critical z values. Alpha is 0.02. Our alternate hypothesis is a two-tailed test. So if alpha is 0.02, and we have a two-tailed test, then we need to take that 0.02 and divide it in half. Okay, we're dividing it in half because of the two-tailed test. Right, and then we do inverse norm because it is z, so we're using inverse norm of the 0.01. Right, so there's our number rounded to two places, be 2.33. It's a two-tailed test, so we need to put both positive and negative. So negative 2.33. Okay, so make sure that you, for a two-tailed test, make sure you divide that alpha value in half. Alright, so this one, the proportion of alpha offers is more than 0.3, and the conclusion is to reject the null hypothesis. Remember, the null hypothesis needs to have the equality. So the proportion of offers is more than 0.3 is in the alternate hypothesis. So if we reject the null hypothesis, then there is evidence that supports this. So B is our choice. Alright, number 5, we're identifying type 1 and type 2 errors. Percentage of adults who retire at age 65 is equal to 62%. So, alright, so that's our null hypothesis. Type 1 error is to reject the null hypothesis when it's true. So that would be B. Alright, reject the null hypothesis. The percentage of adults who retire at 65 is equal to 62, and that percentage actually is 62. Alright, type 2 error is failure to reject this when it's false. So fail to reject the null hypothesis that the percentage of adults retire is equal to 62 and the percentage is actually not equal. different than 62. So that would be A. Fail to reject. Yeah. 6, this is just a notation question. This how many answered no, this how many answered yes, this how many had no opinion. What's the sample proportion of yes responses? So for yes, we take the number of yeses, which was 471, and we divide by the total number of responses, which is all 3 of these added together. Alright, so 0.227, 3 places, and we use p hat. Alright, so here we're actually finally doing a hypothesis test. Now, on your calculator, there are 3 main ones that we use and for our course. And there's others, but for our course, we only did the t-test, for hypothesis test. The t-test, the z-test, and then down here the 1-prop z-test. These 2 are for claims made about a mean. This is for claims made about a proportion. Obviously, by the choices here, our claim is about a proportion. So that's going to be the 1-prop z-test. Alright, the claim. In a study, this many babies were born, this many were girls. Test the claim the probability of being girls greater than 0.5%. Okay, that's our our alternate hypothesis. Greater than 0.5%. That means our null hypothesis has to have equality, so it has to be equal to 0.5. So we want p equals 0.5 for the null, and then p is greater than 0.5 for the alternate, so that's going to be F. Alright, now, once we know that, then we can run the test. So 0.5 goes here. Okay, this symbol right here, that null, is like the null from the hypothesis right there. X is 225, N is 390, and we're doing a right-tailed test, or greater than. Right, now the very first thing it computes is the test statistic, so this is it. 2 decimal places would be 3.04. The p-value is right underneath that test statistic, so 0.0012. Alright, and in the conclusion, the teeny tiny p-value and the large test statistic tells us, but anyway, there's our significance level, 0.01. We're well below that, so there is sufficient evidence to support the claim that the proportion of girls is greater than a half. And does the method appear to be effective? Yes. Okay. The study is able to show the method effectively increasing the probability of a girl. Right. We've increased it because we're in support of the alternate hypothesis. Alright, same thing. Again, we got a 1-prop z-test, so I'm going to go ahead and call it. Alright, this time 79% said that they use the internet. Is it okay for a newspaper reporter to write that 3/4 of all adult users use the internet? Why or why not? Okay. Null hypothesis would be, again, the equality. So 3/4 is 75%. So we find 75%, and the null hypothesis, that's either B, C, or F. Alright, and then if it's not okay to write that, then it's not equal to that. Right? So we would use P equals 0.75 for the null, and then the alternate would be P is not equal to. Okay, and then we're going to do our test statistics. So this is our null, 0.75. X is 79% of 3006, so 0.79 times 3006. I get that, and then round it to the nearest whole number, so 2375. Right, out of 3006. We're going to do a not equals to. So the test statistic to two places is 5.08 roughly. Oops. 5.08. P-value is right below that, which is scientific notation. There's 6 leading zeros, so to 4 places, that's just a bunch of zeros. Alright, then identify the conclusion. Alright, we definitely reject the null hypothesis. Again, this p-value is so low. There is sufficient evidence to warrant rejection of claim 3/4 of the internet use. 3/4 of all adults use the internet. Reporters should not write 3/4 of adults use the internet. Okay, because that number is actually a little bit higher is the problem here. It should be probably, even if we did a right-tailed test, it would be less probable. I mean, even though it's virtually 0 here anyway, this scientific notation number will be even further. It would be probably even well, basically half that value. Alright, so here we got another 1 prop Z test. I know it's 1 prop Z because, again, I'm talking about test the claim that the green flower repeats occur at this rate of 24%. So we're testing the claim about a percentage or a proportion. That's 1 prop Z. So once again, I'm going to stat test 1 prop Z. Alright, the rate is 24%, so as a decimal it's 0.24. X is 22.717% of 8024, so 0.2217 times 8024. Okay, round that to the nearest number, that'd be 1779 out of 8024. And does it give a direction? No, it doesn't give us a direction, so we use not equal to. Alright, so negative 3.84. Alright, again, another low p-value. Scientific notation again, so 0.0001 4 decimal places. And again, there is significant, sufficient evidence to reject the claim. Alright, can a hypothesis test be used to prove that the rate of green flower peas is 24% as claimed? No, that's not how a hypothesis test works. It's reject the equality, which basically is in support of it not being equal in some form, greater than or less than or not equal to, but not, it doesn't support equality. It rejects equality in support of some form of non-equality. Alright, now we're moving to mean. So for this one, I know when I go to my test menu, I'm either going to use z-test or t-test, one of these two, because 1 prop z is for proportions, and I know this isn't proportions, well, from reading it, but also in these options, all I see are means. Okay, so I know I'm going to have either a z-test or a t-test. Now remember, the difference between these two is for z, you know the population standard deviation, which I do here. So this is a z-test. Alright, I have the stats, the claimed mean, 190 seconds. So we need equality in the claim, and then it says greater than. So we need equals in the null hypothesis. This is the only one with equals, so that's D. Alright, and then we're going to run our test. So 190 here, standard deviation of 54.5. Our sample mean was 252.5. Sample size was 50. And we are going to be greater than. Alright, so there's our test statistic, 8.11, which is ridiculously large. Alright, Z here is going to be, almost 0. 15 leading zeros to 3 decimal places. That would be 3 zeros. Oh, I'm sorry, that's the critical values. I'm looking at the wrong thing. I went back and read that. I was looking for p-value again. Critical values. This is a 0.05 test. This is a right-tailed test because of the greater than. So when we come up with our critical number, we need to use inverse norm 1 minus 0.05 because it's in the right tail. Right, if it had been left tail, I would just put in inverse norm 0.05. But because it's right tail, I have to put in the positive version of that number. So 1.645. Alright, and again, with the test statistic that much further away than the critical number, we reject. There is sufficient evidence for the claim sample from the population being greater than 190. So there is evidence of the alternate hypothesis. This suggests that the advice given in the manual is no longer sound. Alright, so once again, we're looking at a either Z or T test because of the means. Okay, the standard deviation of all salary professional football coaches is that. So this is again a Z test. Let's give us a population deviation. Alright, the claimed mean is 500,000. What I just read, the standard deviation of all salaries of professional football coaches is 465,982. Alright, our sample of 45 had 415,229, and our sample size was 45. Okay, oops, I didn't set the test up yet. Less than 500, so we're going to use a left tail test. Alright, so we're going to have it equals here in the null and less than in the alternate. Alright, run the test. So there's our Z, negative 1.22. Critical number here. This is a left tail test, 0.05 level of significance. So this time, since it's left tail, that's just inverse norm level of significance. So negative 1.645. And now we're not into the critical region. We're not beyond this number. So we fail to reject because there is not sufficient evidence. Okay, anytime we don't fall beyond the rejection region, we fail to reject. 12 is just vocabulary. DF, degrees of freedom. 23 is our sample size, so 22 is our degrees of freedom. So that's this one. Alright. Degrees of freedom is always 1 minus, or your sample size minus 1. Alright, so for this one, we're trying to determine whether we have a Z or T distribution or neither. We got a claim about a mean, so that's Z or T for sure. Sample data, we got 43 in our sample, that's important. There's our sample mean, there's our sample standard deviation. Sample appear to come from a population with a distribution that's very far from normal. It's very skewed. Well, that doesn't matter because our sample size is 43, so that makes up for that. And the population standard deviation is unknown. Right? So since it's unknown, we're using the sample standard deviation here. It's going to be a student T distribution. Okay, for it to be normal, which means it's a Z distribution, we'd have to know this value. Okay, that n equals 43 still gives us a bell curve, but without that population standard deviation, we have a particular student T distribution, not the normal distribution. So that's our choice. Alright, so here we got another hypothesis test, this time again about a mean. But I know it's going to be a t-test because it's talking about t-values. The t-test statistic is t. So I know it's going to be a t-test just by doing that. But again, if all that stuff wasn't available to me yet, the way I know is that it's talking about a mean. And I know the sample standard deviation, but I'm never given the population standard deviation anywhere. Okay, that's really the criteria that you're looking for. But because I never see z in here, I just see t's, and I know it's a t-test. So I come over here, I select t-test. Alright, and again they give me stats. So I'll set the test up. This is our setup. So we need equality in the null hypothesis, so it's not going to be C or D, it's going to be A or B. And it says greater than here, so that means it's going to be B. Oh, sorry, A. Right here, the greater than symbol. Alright, and then we're going to set it up. Our claim is 131. Our sample mean is 132. Sample deviation is 12. Just grabbing that one from right here. Sample size is 24. And this is a right tail test. Alright, so our test statistic is 0.408. Always make sure to see how many decimal places to round to. Okay, we rounded the last several test statistics to 2 places, and now we need 3. So just pay attention to that kind of stuff so you don't get something wrong for that type of thing. Alright, 0.3434 is our p-value. So it is greater than 0.1. Alright, critical value using the t table. Alright, if you need it, it's under the it's in Moodle. If you want to open it up, it's also in your textbook online if you want to look at it there. Okay, again, but the way this works, alright, we have sample size 24, so that's 23 degrees of freedom. The level of significance is 0.05. And this is all in one tail. 0.05 is an area in one tail. 23 degrees of freedom. So 0.05 is the area in one tail. Right? We have 23 degrees of freedom. Alright, so that intersects the 0.05 right there. 1.714. Alright, our test statistic doesn't fall beyond the critical value. It's before it in the bell curve. So we fail to reject the null hypothesis. And we don't have support of the alternate claim here of greater than 131. Alright, last question. This is also going to be a t-test. Again, the reason I know it's a t-test is because it says test the claim, right, that the mean weight, so it's a test about a mean, so it's only z-test or t-test, but it's testing about a mean weight, and nowhere in here am I given the population standard deviation, so it's a t-test. Now, I have all these data values here that are given to me, so I'm going to put them in my calculator. Alright, so I've got them in there. Go to stat, come over to t-test. Alright, and then this time I have data. I've got the values put into the calculator. So I have data. The only thing we have to put in there now is claim. Alright, so test the claim that these bats come from the same population have a mean weight of 1.8 grams. So that's our claim value. And then it just asks, alright, where's your data? So it's in this one. I don't see any distinct direction, so I'm going to do a not equal to. Alright, so there's our test statistic. And our critical number here, this is level 0.05. It's the area in 2 tails this time because we have a non-equals to. So the area in 2 tails is 0.05. Okay, we have 14 degrees of freedom because the sample size was 15. So 2.145 is our critical number, and our test statistic is negative 2.045. So we do not reject the null hypothesis. This number falls between the two critical values, meaning that it's not in the middle of the bell curve. Alright, so here's our two critical numbers. Alright, these are our critical regions, these shaded areas in the left, and we've got, oh sorry, calculator, negative 2.045. So we're close, but we're not quite there. Okay, so we're supposed to fall in this region to reject, or this region, if we happen to get something bigger, but we didn't. We weren't far enough away. The claim value ends up being 0 when we standardize everything. We weren't far enough away from 0 to reject that claim is true. So it falls between those two critical numbers, so we don't reject the claim. Alright, so there's the test done with basically just the calculator, and a little bit of vocabulary understanding, just knowing what things mean. Alright.